If you haven't heard of a tile map before, think of it as a resource-friendly way to build 2D levels. Instead of just drawing the whole thing as one absolutely massive image, you break it down into small blocks that can be reused over and over again. On some of the early games like Mario, where they were really pushed on the amount of space they could actually store these textures in, you'll notice that certain assets like bushes and clouds were reused for each other as a way to conserve memory. And of course all the brick tiles and all of that sort of stuff was reused over and over again to build the levels and to build different levels. So what we've got to do is add in a layer that is just going to hold all of these tiles and of course handle their parallax effect. So first thing I'm going to do is come back to the game scene and add a layer. So VAR, layer, game world. This is going to be equal to a SK node for now. But just like the backgrounds, we're going to build a layer that will then control the entire tile map. Now I don't want to instantiate this yet, so I'm just going to tell it what type it is and make it an optional. And this question mark denotes an optional. Okay, so now under layers, just come in and create a new layer called layer world using the Swift file template. Okay, so I'm just going to import some standard code. A lot of this was borrowed from the Games by Tutorial book. They have a section in there on tile maps that is quite detailed, and they go over making this section of code. But just to run through it quickly with you, these top instance variables are to hold the size of the tiles, the texture atlas being used. So we're going to pass in a texture atlas that contains all of the tiles that are going to be used. The grid size, so how many tiles high and how many tiles wide the level is, and the layer size. So this is the physical size of the entire layer. Okay, so this first updates node function, I actually added this earlier and it's pretty similar to what we have in the layer background, where if something disappears off screen, it is then removed. In our background layer, we moved it to the end again, but in this one we're actually just going to move it just to free up some memory. Because if it's off screen, we're not going to use it again. Down here in the init, this is mostly used just to set up those instance variables that we just went over before. The convenience init, so this will be when you pass in which texture atlas you're using, the tile size and the tile codes. The tile codes will refer to what type of block each of these tiles is. So if it's ground, if it's air, if it's just some scenery, we'll know what it is by this string. So you can see here that it is in brackets. This is because it is an array of strings. The node for code function, this is run for every single tile that is in your array of tiles. Just to clarify a little further, let's say that the ground has a code of G for ground. Then any tile with a G in it will then be a ground tile. If it is A, then it'll be air. How these tiles are decided, we're going to go over soon, but for now just know that that's how it's working. We're passing in a single character, and in return it is passing back a SK node that has been built based on the character that has been passed into this function. So I prepared this list earlier. I recommend making up a little list like this for your reference every time that you're using tile maps. So what I have over here in the left column is the code that I'm using. Make sure that it's only a single character, so if I was going to go to 10, that would be a problem. It would actually come across as 1 and 0. So there is actually a limit this way to how many codes you can have. But for this sort of project, that'll be okay. So in the type column, I've just put what type it is. So top might be just ground level, top left would be like a corner piece. In the next column, I say whether it is collidable, so whether it collides with the player. Then we have destructible and collectible. So this is a good, handy guide to have with you when you're doing anything like this. Okay, so I'm just going to start making one as an example. So in this switch statement, I'm going to put case 1, so in the event that this is 1, assign the tile to a SK sprite node using a texture from the texture atlas, and the texture is going to be called 1. Now you can see over here on the right, where we have the resource files, that 1 is a top left corner piece. So that defines how it looks. Now I'll just give it a Z position so that it will appear at the front. Let's add in number 2 as well, just so that there will be actually something to see when we load up a sample map. Now if I come over to the content, you'll see that I have some sample tile maps that are just built in text files. So if you have a look here, you can see the 2 that I put is at ground level, and after that there'll be a K, which is scenery, or it might be a dot point, which is just air. You don't need to learn all these codes just yet, but as you start creating a few levels and even assigning your own codes, you'll soon get the hang of this. So I'm just going to come back into the game scene and change this from a SK node to a layer world. Okay, so in SKT utilities, there is a extra class which doesn't actually come with SKT utilities, but I thought I'd add it here anyway because it's pretty much taken exactly from iOS games by tutorials. What this does is it passes the text file and it returns a layer already set up with all the codes in it and everything in it. So I'm just going to make this layer game world equal to tile map layer from file named level 1. Because it is an optional, I'm going to check that the layer is not nil before continuing and set its velocity to 160. Now I can add it to the world. Then if I build and run, you'll see that our number 2 piece has come up perfectly. However, it's not actually moving. This is because we forgot to update our update function in the game loop. So we come down here, layer game world, put a question mark after it because it is an optional. So this will mean it will run this function if it is available. So .update, delta time, affect all nodes, yes, parallax, yes. Now if you build and run again, the level will now move accordingly. Okay, so it looks pretty good. Now we've got to add the rest of these codes in. So if I go through all of those and copy and paste from the previous, then update it so that it is the correct key and the correct texture. Now when I build and run, the level will be fully filled in. The level still looks pretty plain though, so we should add some scenery to it. So in the case of K, we're going to pass it an array of names of textures. So this SK sprite node is going to be based on a texture from an atlas, and the texture is going to be named based on a random index. And this index is going to be decided between 0 and the number of strings in this array. And I'm also making the Z position random so that when we add our character, the scenery may appear in front of the character or behind the character, and this will add a pretty cool effect. I could go through and add each of these scenery items as their own case, but that will use up a lot of my time in updating the content so that there's enough variety, and also we'll run out of numbers and letters pretty quick as well. So build and run again, and there you go, our level is now full of beautiful scenery as well as the landscape. So that all looks pretty good. Now we need to look at bringing an actual character into this landscape.